my screen is that workbook 4. I'm assigning it. It's these 6 problems, and they're due the following Friday. If this section works out like my previous section, I'm just going to do all the problems here in class. So then you can just turn them in and get them over with. So, but initially, yes, this is the next workbook assignment, and as I mentioned in class last time, today is just a homework review session. So if you have any homework questions about anything, so mainly this pertains to equations of the quadratic type. This homework is due tonight. So this is the substitution type problems. There are 14 questions, and if anything, I'm going to do the last 2. I think the last 2 are a little tricky, so I was planning on doing the last 2. But if anyone had any requests for any homework problem you might want me to do from either that section or the grouping section, which is the next homework, you can go ahead and ask me now. Otherwise, I'll just do the workbook pages, and then I'll do those problems I mentioned and talk about the exam a little bit. If that sounds fine, you could just hang around. If you do have any questions, you can just ask me at any time. I'm just going to go ahead and start talking about the workbook pages, the assignment. Okay, so Hannah, you said number 8. Take a look at number 8. So I'm actually going to be, so this one's a good one to ask. I'm actually going to be talking about this. This is one of the workbook problems. So I hope you don't mind. When I go through the workbook problems, I'm going to be talking about a problem that looks just like this one. It's in particular, it's number 2 on page 14 of the workbook. So hopefully you're okay with that. But I'll be doing a problem just like it, as you'll see. So let me just go ahead and do the workbook problems. It might reflect a lot more than you think. So I'm just going to go ahead and start doing those, and we'll go from there. What's that? A pencil. There's one up here. Set up. Oh, that sucks. Okay. Let's see. Here, you can just have it. I don't care. Okay, so let's go ahead and look at these problems. So we'll start off with page 13, number 1, which wants us to determine the real solutions for 3t plus 4 is equal to 2. So hopefully you see the radical and you think, all right, this is a radical equation problem. And so how did we handle, and this thought process will be good going into the midterm. If you identify the radical, then you think to yourself, how do I handle equations with radicals? First thing we did was we isolated the radical. Well, in this problem, the radical is already by itself. So step 1's already done. Once we isolated the radical, then we get rid of the radical. So I'm just going to rewrite it to really emphasize that to get rid of a square root, we have to square both sides to get rid of a square root, which means the square root and the square cancel. And now we get 3t plus 4 is equal to 4. So this is the same thing as 3t is equal to 0 after you subtract 4 on both sides. And so t is 0. do need to check our answer, because whenever we have even root in the beginning of the problem, we sometimes have extra solutions. Turns out this one's going to be fine, but just for consistency's sake, check the answer means plug in that solution we found. And the equation holds true. We plug in 0 for t, we do in fact get the 2 that's on the other side. So this one's good. That would be your answer. So that's it. The next workbook problem is number 2. And this now imposes a fourth root of 3t plus 4 is equal to negative 13. Now, there's something you may notice about this problem in the very beginning that makes this problem actually very easy. Thing to notice more so, an even root cannot output a negative. So I've mentioned this in class a few times. Even roots cannot have a negative number as an output. And by noticing this, you could say that there are no solutions. So, no solutions. That's it. That's all you do in the problem. Now, if you were to not notice this, if you did not notice this, you would take the fourth power of both sides to get rid of the fourth root. You would find an answer, but when you check your answers, you would end up getting that final solution did not work. As in, if you plugged it back into the equation, you would probably get something else. You would not get negative 13. So if anything, if you're able to identify it in the beginning as such, you will save yourself a lot of work. The last one I assigned on this page is number 4. This one wants us to find the solutions for the square root of x squared minus x minus 4 is equal to x plus 2. So we have an equation with a radical sign in it. So the first thing we have to do is isolate the radical, which the radical is already isolated. So the second thing we have to do is, well, get rid of the radical symbol. So I'm going to rewrite the problem, emphasize that the next step to get rid of a square root is to square both sides. Square gets rid of a square root. Square root and a square. So over here, now we just get everything, well, the radicand, everything underneath these square roots. And on the right-hand side, x plus 2 squared needs to be FOILed. You need to FOIL this. So that's why I'm going to write it as x plus 2 times x plus 2. So we can FOIL this. First, outer, inner, last. So x times x is x squared. X times 2 gives us a 2x. 2 times x is another 2x. Then 2 times 2 is 4. So just foiling it. We can go ahead and subtract x squared on both sides. And we can simultaneously go ahead and combine these two x's together. So we'll do two things at once here. So the x squareds all cancel. And we're left with negative x minus 4 is equal to 2x plus 2x, that's 4x plus 4. Add x on both sides. 4 is equal to 5x plus 4. Now we can subtract 4 on both sides. 5x is equal to negative 8, and so x is equal to negative 8 over 5. You would. So well, negative 8 is just the negative 8 is just negative 4 minus 4 here. So I just put it over here, right there. So negative 4 minus 4 is negative 8. And so if you were to check your answer, because technically you would have to, because this is a workbook problems, generally the workbook problems are more difficult. So this one just ends up working. If you do want to check it, if you check it correctly, if you plug in the x on the left-hand side, you will end up getting 0.4. And if you plug it in on the right-hand side, you will get 0.4. So it will work. I'm just not going to work it out. Because generally the workbook problems are more complicated than your actual homework. And then fractions tend to be a little messy. So I'm going to just leave it at that. So we'll move on to the next page of the workbook. And then Hannah, to answer your question, I'll be doing problem 2. So page 14 now, number 2. Oops. And so what this says, and this is also one of your problems in your U substitution homework. So this is number 8, as Hannah mentioned. So this is number 8 from the homework. X plus the square root of x is equal to 20. So here, so this is from the substitution section. So technically, you can do this problem in one of two ways. You could either isolate the radical and eliminate the radical, or you could use U substitution. I'm going to stay consistent and use U substitution here. But you may also solve for the radical and then square both sides and work it out that way, if you wanted to. So we're using U substitution. And as mentioned, normally the middle variable gives us an idea of what the substitution will be. This makes sense because if we were to square this expression, and all we get is x, which is great because that tells us how to replace this one in front. So the x is now u squared. The square root of x is now just u. All of that is equal to 20. And we can quickly go ahead and subtract 20 on both sides. To put this in standard form, so that way we can go ahead and factor. It's like u plus 5 and u minus 4 equal to 0. Which ends up being u is equal to -5 and +4. However, using u substitution, it requires us to convert back to x values instead of u values. We don't want to end with u values, we want to conclude with x values. So how do we go from u's to x's? Well, we need to utilize this rule here. So we're bringing the rule back. And we're going to apply the rule for each value of u that we found. So one of the u's we found was -5. So now -5 is equal to the square root of x. And another u we found was 4. So now that's equal to the square root of x. Now one of these is much easier than the other one to solve for. The reason why is because there's an interesting correlation between the square root and the -5. So I just mentioned this before. The square root cannot output a negative number. The square root cannot output a negative. I wrote this for, I think, the second workbook problem that I went over. So this cannot happen. So over here, you get no solutions. That's just for that side. And that way, by identifying that early on, we are able to already toss the extra solution. So that means we don't have to check our answers at the end. We already tossed the extra answers. On the other side, well, 4 is positive, so this is okay. So we can go ahead and square both sides to get rid of that square root. So now we get x is equal to, well, 4 squared is just 16. And that would be your final answer for this problem. All right, I'll go on to the next workbook problem. So number 4. So this says 4x to the third is equal to 3x squared. So we might have done a problem fairly similar to this in the the factoring by grouping section. But in any case, the first thing we would really like to do, we have all polynomial terms, so that means we want to put this into a standard form. Standard form meaning we have all the exponents in decreasing order, and everything's equal to 0. So we need to get these terms, in other words, we need to get everything on the same side. I would rather put everything on this side. I'd rather move the 3x squared over because I want the highest degree term to be positive. So I want the 4x to the third to be positive because it has a higher power. So it makes more of a difference. So upon doing that, 4x to the third stays, and now we're subtracting 3x squared to move it over. And now there's nothing on the right-hand side, so we can put is equal to 0. And now we can go ahead and factor, now that this is in a standard form. So it turns out that since there's only 2 terms, we can go ahead, well, there's 2 terms and they have stuff in common. They both have x squared in common. So we can factor out x squared. So when we factor out x squared, 4x to the third, well, x to the third, we took out 2 of the x's, so now we're just left with 1. The 4 is still there. And then minus 3, because we just factored out those x squareds. And so now from here, each individual component can now be individually set equal to 0. And so now we can solve for x in both cases. For the left side, we would take the square root to get rid of the square, which would give us a plus or minus. However, it doesn't really matter. The square root of 0 is just 0. Plus or minus 0, still just 0. So if anything, we have one solution from this side. And so now we need to solve the right side. The 4x minus 3 is equal to 0. Add 3 on both sides, divide by 4, and we get this as the other answer. So these are the 2 answers that we get for this problem. All right, the last one I assigned for this workbook assignment, number 5, should be a fairly straightforward one, I think. X to the third minus 3x squared minus 16x. plus 48 is equal to 0. And hopefully you can look at this and identify that this will be a grouping problem. The reason why it's grouping is because there are 4 terms. So when you have 4 terms, you think factoring by grouping. So let's go ahead and group stuff. Group the first 2 terms and the last 2 terms. What the first 2 terms have in common is an x squared. Both have x squared in common. So what are we left with from the first group? Just an x for the first term, and then minus 3. We took out 2 of the 3 x's from x cubed, so now we're just left with x, and then minus 3x squared. We took out the x squared, so it's just minus 3. For the next grouping, well, if anything, this tells us the pattern that we need to anticipate. So whatever we have, we better have an x minus 3 show up in the next group. If we factor out just 16 from the next group, we will be off by a negative sign. We talked about this in class. We're going to factor out a negative 16, because when we factor out a negative 16, well, if we take negative 16 out of negative 16x, we're just left with positive x, because the negative went with the 16. And then 48 divided by negative 16 is negative 3. So notice we get exactly x minus 3 again. And so now we have x minus 3 in common. We can factor out x minus 3. So what are we left with? X squared minus 16. Here's the x squared, and then here's the minus 16. Now we have a factored form. And so the good thing about factored forms is we can split up the factors individually equal to 0. So x minus 3 gets its own 0, and x squared minus 16 gets its own 0. One of them is pretty easy to solve for. X is equal to 3. Then over here, we have to do a few extra steps. Add 16 on both sides. Take the square root of both sides to get a plus or minus. So we end up with x is equal to plus or minus 4. So we get 3 answers. And so that concludes the workbook assignment that is due really a Friday, well, the following Friday. So you get that written up and you submit that to me, then that's all you need to worry about outside of the midterm as far as next week goes. So does anyone have any questions before I proceed with other stuff? So if not, while I have all of you in here, I do want to emphasize that although I received a lot of requests for people to take the midterm remotely through ProctorU, I have not had many people sign up for ProctorU. And so you need to you definitely 100% need to get this done by tomorrow at midnight, or else ProctorU will charge a late fee if you sign up. If you keep pushing this off and you sign up at the last minute or something. I sent out an email to everybody, not just people who wanted to take it and reached out to me. I sent out a class email about how to sign up for ProctorU, and I had a few people sign up already, so, but not many. So if you do not sign up through ProctorU, then it is assumed that you're either taking the test, in person or in the testing center if you have the appropriate accommodations. So you really need to get the ProctorU account set up, and you need to sign up for it by Thursday at midnight, or else ProctorU itself will charge a late fee for you signing up late. So I guess since I have probably as many of you in here as I will have for a while, I'm really emphasizing that now. So, so yeah, that takes care of ProctorU. Additionally, I suppose I will go ahead and talk about two problems from the homework as well that's due tonight. The last two problems are a little tricky, and I wanted to talk about both of them. So it's problems 13 and 14. When I look through it, I feel as though my lecture covers all the other problems. But I think 13 and 14 are a little tricky, and I wanted to talk about these two. So this is number 13 from the homework. So this is number 13 from the homework that is due tonight. So this is number 13 here. So this is a substitution problem. Comes from the substitution section, and normally the middle variable gives us an idea of what the substitution will look like. So if u is equal to x to the 1 over 3, what about x to the 2 over 3? Well, if you like the derivation stuff, then if you square both sides of the u that we established before, that would be x to the 1 over 3 quantity squared. So that would be x to the 2 over 3, which is exactly this second term here. So from here, we can now apply the u substitution as 4u squared minus 35u minus 9 is equal to 0. And so from here, we have a quadratic that we need to either apply the quadratic formula or the AC method. I'm going to apply the AC method, or whatever factoring technique you want to use. It doesn't matter. You can use the quadratic formula as well. You'll get the same exact answers. So we get negative 36 for AC, two numbers that multiply to give us negative 36 and add together to give us negative 35. I see negative 36 and positive 1. Which means I can replace negative 35u with negative 36u plus u minus 9 is equal to 0. And from here, since we have 4 terms, we could factor by grouping. The first 2 terms, what they have in common is they both have 4u in common. So 4u squared, we took out 4u and we're just left with 1u. 36 divided by 4, that's 9. And we took out the u. And it turns out this pattern is exactly the pattern right here. So really, we don't have to factor out anything. Or if it makes you feel better, you can think about an understood 1 being out here. We can factor out this common u minus 9. We are left with 4u plus 1. And so we have a factored form. That means we can set each one of these individually equal to 0. So we can set both of these equal to 0 and solve for u appropriately. Here u is 9. Here u will be negative 1 over 4. The problem with this is we're not done, as we have u values and we want to conclude with x values. How we do that is we need to take our substitution and bring it back. So we bring our u substitution rule back, and we break it up based off of how many u values we found. Which we found 2. One of the u's we found was 9. The other one we found was negative 1 over 4. And finally, we just need to figure out how to get rid of x, or how to get x by itself, rather, by getting rid of the 1 over 3 exponent. So if you think about it, x to the 1 over 3 is the same thing as the third root of x. We talked about this in the radical expressions homework. As such, we can consider these as third root of x, third root of x, and we know how to get rid of a third root with a third power. Same thing over here. Nine to the third power, 729. Negative 1 over 4 to the third power. Is negative 1 over 64. These would be the 2 answers. We do not need to check our answers because we were dealing with third roots. which are odd roots rather. These are odd roots. We do not have to check our answers with odd roots.
I have a question.
Yes.
When you did the AC method up at the top, I thought you were supposed to use two terms, like two of the numbers to do the AC method.
1 second. Let me scroll back up here. So for the AC method, ask your question again. I have it up here.
So did you just use 35 and U to get your numbers for the AC method?
So for the AC method, so when you refer to A, B, and C, you're referring to here's A, here's B, and here's C. So the 4 would be A, -9 is C, and that helps us give the 36. But yeah, the point is you have to split up that AC number, which is -36, to where they add together to give you the -35. And that's why I chose these two, because notice -36 plus 1 is -35. Worked out perfectly. That is B.
So what about the -9? Like I thought you were supposed to use, wait.
You said, what about the
Okay,
-9?
wait. I don't know, I'm confused.
So, I mean, in order to get to the -36, we have to multiply two numbers to get to -36. What numbers do we multiply? Well, the AC method says we have to multiply the first number to the last number, no matter what. That's how we get the number in the first place. But it doesn't mean that that's the pair that we have to use in the AC method moving forward. So we use the -9 and the 4 to help us generate the -36. But after that, then we need to just think about, all right, well, there could be another pair that actually adds together to give us the -35, which happen to be -36 and 1, and +1.
Okay.
So if you're having issues seeing the AC method, so the AC method, you could probably find a pretty good tutorial online to sort of clarify some of the loose ends if you need to. But that's the motivation why I did it this way, this problem.
Do we have to always do it that way, or is there a different way? Because I understand the AC method, I just don't understand this question. I don't know why.
You said you understand the AC method, but you don't understand this question.
Like this specific question. I don't know.
Yeah, I'm not too sure what to tell you at this point. This is just applying the AC method to just another quadratic. And I suppose I don't really see what you're asking.
It's okay, thank you.
Yeah, maybe just, I don't know, write it down for now and just look at it and let it, wind around in your head a little bit. And if you're still having questions, you can just email me and we can talk through there. Sometimes that helps, but besides for that, I will go ahead and do one more problem from the homework. And this will be problem 14 from the homework. So this one definitely is a little tricky as well. so for this one here, definitely trickier than the other ones, and it's in the substitution section, which implies we have to use some sort of substitution. Now the question is, what would the substitution even be in this problem? There's fractions and stuff. I want to make one slight modification to this problem, which will hopefully make the substitution a little bit more clear. And that is, I'm just going to move the 2 out to the front of the fraction. So this means the same exact thing. I just brought the 2 out to the front. And the reason why I did this is now we see this explicit pattern here. V over V plus 2, and then V over V plus 2 squared. That instantly tells us our U that we can utilize. So U is V over V plus 2. And there's a few other ways you can do this problem. You could use the least common denominator, and that's perfectly fine as well. I think this way will clean it up this will clean it up very nicely. So by making U this fraction, we would now get U squared plus 2U is equal to 15. And we can quickly go ahead and move the 15 over to put this into standard form, so that way we can factor. So here, if anything, the quadratic itself is fairly reasonable. And now we need to go back to x values, which means, or rather, technically v values. So we need to bring our rule back. So the rule is u is equal to v over v plus 2. So one of the u values we found was -5. So now that's equal to v over v plus 2. The other one we found was 3. And we need to solve both of these. So in both cases, we can cross multiply, which would give us -5 v plus 2 is equal to v, and 3 v plus 2 is equal to v. Go ahead and distribute and distribute. -10 is equal to v, and then 3v plus 6 is equal to v. Over here, we would get -10 is equal to 6v. And over here, we would get 2v plus 6 is equal to 0, just combining some like terms. And so we get that v is -10 over 6, which would need to be simplified to -5 over 3. And then over here, 2v is equal to -6. So then v is equal to, well, -3. So we get 2 answers. Does anyone have any questions about any of this? Because if not, this is pretty much the extent I got to with my other section. And so I will call it a day here. If you do have any extra or other questions, I will stick around. But just most importantly, please sign up for ProctorU if you haven't done so already. This homework is due tonight, and I just did the workbook assignment, so you have until October 2nd to turn that in. Other than that, that's all I have, and have a good day. Thanks.